Hello, everyone. Today we're going to be talking about several different types of data collections. In fact, this whole week, the Unit 3-1 week is all about data collections, different ways that we can store and organize data for our programs. And we're going to start today talking about some advanced concepts of lists we've used before, or some more ways to work with them, but also we're going to talk about a data structure called a tuple. So let's go ahead and get started. All right, so we're going to be chatting about lists and tuples today. And the primary two concepts here are, what's a way that we can store a sequence of values, that we can extract the individual elements from that sequence and work with them, but we can refer to them all with a single name. So a list, for example, is a data type where we can have a lot of different data, strings, integers, floats, whatever we need, but we can refer to the whole thing, the entire data collection, with a single name. The same thing is true with the tuples we'll talk about today as we move forward. So let's chat a bit about lists again. We're going to work with lists a lot for the rest of the semester. You've already done some work with lists. You're going to get a lot of practice working with them. Lists are the very flexible data structure within Python. Some other programming languages have different names for something that's similar to a list, but a Python list is a unique thing. Have no doubt about it. A Python list is a very special type of data structure. So we're going to talk about how we create and structure our lists, how we access the individual elements, looking at things like the length of a list or whether something is inside of a list, whether a list contains a specific amount of data. We'll do a little bit of practice and review on slicing and manipulating lists, and talk about looping and lists, as well as some list methods and how we convert lists to strings and back again. So it seems like a lot, but some of these topics are review topics. I just want to make sure we get a chance to actually look at them again. So we've talked about this once before. It's very important that you know how to use a list, but even more important, it's not what we're going to store in the list, but how it's structured or organized. So in this case, I have two lists, one called F names and one called L names. So first names and last names. And I have the four names here in my first names, Will, John, Yolanda, and Zeb. And I have the four names in my last names list. And how do I connect the two things together? It's something that many of you did for Lab 2-3. You had a list that contained the entry boxes in our grade calculator, and separately you had a list of the weightings for calculating a grade, right? Some things were worth 5%, some were 10%, some were 20 or 25. And so you can connect these two together because you made sure that they were set up so that the corresponding values were the same. The entry box for participation is worth 5%. The entry box for homework is worth 10, and etc. You had two separate lists, though, with the values. So how are they connected? The index where the value is stored is the connection. And the same thing here. At index 0 in F names is Will, and at index 0 in L names is Carson. So when I set up a for loop, for j in range, the length of first name or F names, it's going to be length of 4. So this is going to give me a range of 0, 1, 2, and 3. Well, that happens to also be the indexes of the names in both lists, 0, 1, 2, and 3. So if I print L name j, so the first time through that's 0, L name j, plus a comma and a space, and then F name j, what I'm going to get out of this little program here is I'm going to get a list of these people's names, last name, comma, first name, all four of them. So there's a little bit of a problem, is that what happens if I change the data? So let's talk about that too. When we look at the index within a list, we can extract data from the list. So if I create a list and it has, let's say, these three elements in it, cats, comma, 2, that's the first element or element 0. Dogs, comma, 3, that's the index 1. And fish, comma, 4, that's index 2. These at each index is another list, which means that we can index within this list as well. So for example, if I say my pets is this data structure, I know how it's structured. Each index in my pets contains a smaller list with the type of pet and let's say the quantity of pets I own. I have 2 cats, 3 dogs, and 4 fish. I don't. But if I did, I have a very busy household, but at least I have my little list here containing all the values. So what is my pet's index 1? Well, my pet's index 1 is this sublist. I'm referring to this list with the string dogs and then the integer 3. And that's what I get back. My pet's index 2, index 0. Wait, can I double index? You can. Remember, my pet's index 1 is this list. Can't I index in that list? Of course. My pet's index 2, index 0. Well, index 2 is this whole small list. And what's index 0 in this list? The word fish. What if I indexed one more time? What if I said index 2, index 0, index 0? Then what would I get? Well, this list is index 2. Fish is index 0, but this is a string. Can we index in a string? We know we can, right? So index 0 of this string is just the capital letter F. So I could index even further here. I need to know not just what data is in my list, but how it's structured so that I can retrieve the data when I need to. When you create your list for your programs, it's important that you take the time to sketch them out, write them out on a piece of paper, even practice indexing them, just so that you know how you can retrieve individual values from your list with these indexing. So don't just start appending things to a list. You need to know what that list contains. Sometimes a few temporary print statements in your program will help you figure out what's in each element. So it's very common to use a loop variable as a list index like I did there. So for example, horseman equals war, famine, pestilence, and death. For I in, and I've got a list here, a sequence. I didn't have to say range of 4. I could just have simply a list, and each of these values will be substituted for I every time the loop repeats. Print horseman index I. So the first time it's 0, horseman index 0 is war. Then the loop repeats, I becomes 1, horseman index 1 is famine, etc. We can also use the list elements themselves. So I could say horseman equals war, famine, pestilence, and death for H in horseman. That's this horseman is this whole list. Each time the loop repeats, one of these strings will be substituted for H. So these two sets of code produce the identical output. And in fact, the exactly identical output. With a little bit less memory usage, because I don't have the extra variable I, and I don't have that extra list 0, 1, 2, 3 to look through. I only have a single list, a for loop, and a print statement. It's more efficient too. You can see it's simpler to understand. And if you were to change this so it said for horse in horseman, then you're naming each of these as well. So it's another little approach. Makes it a little more readable like natural language. So using the length function, we can determine the length of a list or any other sequence, string, list, tuple, we'll talk about briefly here in a little bit, to allow our program to access those indexes when we don't already know their length. What if we don't know how long the list is? Well, for I in range, length of horseman is 4. So range of 4 is going to give me 0, 1, 2, and 3. If I add more elements to this list, I can run the exact same program and it'll print them out one at a time. It doesn't matter how long it is. We're telling Python, get the length of the list and loop that many times. So list operations, we can use things like plus. Remember strings? If I have 2 strings, Gary and McFall, and I say string Gary plus string McFall, I would get Gary McFall smushed together, right? So we can do that with lists as well. If I have a list named A, that's 1, 2, and 3. I have a list called B, which is 4, 5, and 6. And I say C equals A plus B. What you intuitively would assume is that the A list and the B list added together becomes a new list, which is 1, 2, 3, 4, 5, 6. And that's actually exactly what happens. This is the same concept as 2 strings of characters added together to make a longer string. The plus operator combines or concatenates lists together the same way that it does with strings. And just like in strings, the asterisk that's shifted 8, the asterisk, sometimes called the splat operator, I don't remember why, well, because it looks like a splat, I suppose, is used in mathematical operations. And if I said a string times 4, I would get a new string with the same text 4 times repeated. And the same thing can happen with a list. Let's say I need a list of 100 zeros, initialized to 0, but 100 positions in the list initially at 0. I could take the time to type that out, left square bracket, 0, comma, 0, comma, 0. Or I could just say 0 times the number of zeros I want in my list. I will get a list. So if I said my list equals square brackets 0 times 4 or times 100, then I'll get a list with that many values. If I do 1, 2, 3 times 3, I'm going to get that same pattern repeated 3 times. So it's a quick way to create a list that you might need for some reason, and the multiplication operator will do that for you. Slicing, of course, works with lists, and we've looked at slicing before. So if I have this list of individual characters, A through F, in quotes, and I said A list 1:3, that's starting index 1, going up to but not including index 3, I just get B and C. Or from the beginning up to 4, I get A, B, C, and D, that's index 0, 1, 2, 3, and 4. Or from index 3 to the end, well, index 0, 1, 2, this is index 3, so 3 to the end is D, E, and F. You'll notice that I put them in here with double quotes, but they're coming out with single quotes. Doesn't matter. Single quote, double quote just means string. Or A list colon. Don't specify a beginning and I don't specify an end. That means from the beginning to the end. This is actually just basically copy the list. And you get the whole list as a copy. Changing and manipulating lists, you can do index values with that too. So fruit equals banana, apple, and cane seed? I don't even know what that is. Fruit 0 equals pear. So now fruit 2 equals orange. Well, this is index 0. We're replacing this string with this one. And we're replacing this string with this one. And if I look at what's now in here, it is as we expect. Pear is at index 0. And then apple is still there. And then orange is at index 2. So we can replace elements and lists this way. Or I can say my list equals these characters. My list index 2 is an X. So now it's these characters from text to text. Using a slice indicator, we can update a sublist or even remove elements from a list. So we didn't think about this. We thought about a slice indicator, a slice operator, as a way to retrieve data. But how about a slice operator as a way to modify the data? So if my list starts with A through F as individual characters, and I say A list 1:3, so from index 1 up to but not including index 3, its indexes 1 and 2, equals XY. Those two characters replaced these two characters. Or A list 1:3 equals nothing. That actually deleted them from the list. It removed them from the list. So you can use that to make changes as well. We can also use it to squeeze in or insert new characters. So if I said my list is A, D, and F from index 1 up to, but not including index 1, insert B and C. You get A, B, and C are inserted in here at position 1, and the list stays. Then I'm going to insert E at index 4, 0, 1, 2, 3. There it is in index 4. So we can squeeze into or insert values into a list exactly where we want them with this technique. So when I set up a loop, I'll say for variable in a sequence, and that could be a list. So friends equals Joe, Zoe, Brad, and Angelina. So I've got this list of friends. And if I name my variables like a list, like a sequence, if I name it something that makes sense, these are my friends, I can actually write for loops and other types of programming structures that almost sound like natural language. So if my friends equals this list of friends, I just have the for. For friend and friends, print the friend. And this actually can be read almost like natural English language. For every friend in the list of friends, print the name of the friend. That's pretty much what this says, right? So if I'm not printing it, if I'm doing something else to it, capitalizing it or making it all lowercase or reversing the string or whatever it is I'm doing, it's still for every friend in the list of friends. Do something with that name. Do something with that friend. This could also be a list of circles. Let's say for every circle in the list of circles, move them a little bit and then keep looping and doing that over and over again. Or for every rectangle on the screen, was the mouse click in that rectangle? So you could do a number of things like that with using these for loops, looking through a list of objects or strings or characters or numbers or whatever it is that you have in your list. So lists have a lot of methods we haven't talked about so far. We have discussed append, and we have talked about things like count or reverse, possibly sort and length, but there's a lot more. You can, if you have a list of numbers or characters, ask for the maximum value in that list. If they're characters, they would be the last one the max would be the last one alphabetically. If they're numbers, it'd be the highest number, right? 0 through 9. And then you've got a sum where you can add up the values. We have minimum. We can reverse a list. There's two ways to do that. You can reverse a list in place, or you can get a copy of the list in reverse order. To reverse a list in place, you use reverse, list.reverse. But reversed with the list name inside the parentheses, this returns a copy of the list in reverse order. Sometimes you don't want to change the list itself. You just want it in reverse order. It's also very simple to convert a string into a list. If I have a string, the rain in Spain, and I want it to be a list, each word being there without the spaces, I can just say, give me the string dot split. If I don't specify anything in the parenthesis, it splits it by white space, which is kind of cool because it means it doesn't matter if that white space is an enter key, like a new line character, a space, 3 spaces, a tab character, it doesn't care. If I put something in the parentheses, like I want to split by comma or something like that, then I can control it that way. But just by taking this string and doing dot split, I get a list that is the characters strings separated wherever there was a space. And you notice there's no spaces kept. They're eliminated. So it's just the string the, a separate string rain, a separate string in, and a separate one Spain. You want to keep this in mind. We're going to be using this in the lectures this week, but also in lab assignments, programming exercises and lab assignments. The ability to take a string and divide it up into a list. You want to keep that in mind. If I have a list and I want to put it back together into a string, that we use the join method. The join method is you take a string, which is a glue, I call it the glue character, and you say glue together that list using this string character. So for example, I've got my list, the rain in Spain. If I say my glue character is a semicolon, S equals glue, and then dot join my list. It's just going to insert my glue character in between each of these strings and concatenate or combine them together using the glue character back into a new string, which is what you see here. So this could be a space, it could be nothing, it could be dashes, it could be anything, right? If you wanted to put your own name in between each of those words, have it say, the Gary Rain Gary in Gary, Spain. You could do that too. You get to specify the glue character that actually joins each of the values in the list together into a new string. So that's up to you. You get to pick that glue character. And if I don't want anything in between them, I can use an empty string, like here's my list, the rain in Spain. And I just use double quotes, meaning empty or nothing, dot join, but this is still a string. An empty string is still a string. That's true. This takes this empty string and joins together the words. So I get a new string, which is those words pushed together with no spaces or anything in between them. You can do that too if you want to. All right, now that's a quick review and some additional tricks and tips for working with lists. Let's talk about something that's similar to a list. It's a sequence, but it's ordered too. We know what's at index 0, 1, 2, and 3, but it's not a list, and there are some differences. One of the primary differences is that a tuple is immutable. Remember we talked about strings earlier this semester, and I said you can reference each individual character in a string by its index, but you couldn't just set that index to something different. You can create a new string and replace the string with a new copy modified, but you can't just change an individual element in that string. It's the same thing with a tuple. We define a tuple using parentheses. So a equals, in parentheses, 1 comma lowercase a comma 45.2. So this is a tuple with 3 values in it, but we can refer to it with a single name. That makes our program simpler because we only have the one name to refer to. Or my tuple equals Pete comma Rowdy. Got 2 strings, they're in a tuple, they're stored together, and I can refer to them by a single name. What's the point of this? Like, why do I need it? Well, we need it because we need a way to transfer and pass characters and values and more than one value between functions. But also, we don't want to have to specify like 25 variables. If I have 25 names in a list, why would I want to have 25 variables? That list, or in this case, that tuple, can have as many names in it as I want to. I still refer to the tuple by a single name. And that's helpful. But tuples are also used to pack and unpack multiple values. You may have seen an error message at some point in all your coding that says too many values to unpack, right? Like for example, if your function returns a single value, but you tried to assign it to 2 variables, right? You got a function called clicked, and it returns either true or false. But you said x comma y equals clicked. In other words, you tried to unpack a single value into 2 separate variables. You'll get a packing error basically. So I can define a tuple a number of different ways. All 3 of these ways work, but so does indexing, right? So I can say from 0 to 2, I can have a tuple length of 0 or even 1. I can still have a tuple as long as I put a comma after the value. It's still a tuple. And this is how we pass parameters to and return values from functions. When I say my function, and in parentheses, x comma y, I'm passing a tuple to that function, 2 values to that function, and then the function unpacks them. You've been using tuples already this semester, and these should look pretty familiar. Early on in the semester, we talked about doing assignments. And in the first or second chapter, there's a subsection called simultaneous assignment, where we can assign 2 values to 2 variables in a single statement. Not x equals 5, y equals -7, but x comma y equals 5 comma -7. This value gets assigned to x, this value gets assigned to y. And when I print x and y, look, I'm passing a tuple to the print function. When I print x comma y, it prints both values. But if I say x comma y equals y comma x, well, whatever was in y gets assigned to x, and whatever was in x gets assigned to y. Again, simultaneous assignment. We've been using tuples all semester long. We didn't call them tuples, but that's what they are. And in this particular case, we're using tuples to flip the values, right? Between x and y. Another thing you've done, you've defined a function. Let's say my function called data. And in data, I create 2 lists, first list and second list. They each have content, an integer, string, whatever. And at the end of my function, I return these 2 lists. I'm returning, effectively, a tuple, 2 values. In the main function, when I call the data function here, I'm assigning what the data function returns to these 2 variables. They're packed up here and returned, and when they're returned, they are unpacked into these 2 separate variables. In between those 2 things, when the function returns the 2 values and when main receives them, in that split instant, they are a tuple. More than one value in a structure with indexes, right? 0 and 1 in this case. And here I have my function called make, which accepts 2 values, a tuple, And in main, when I call make, I pass it a couple of numbers. I pass make this tuple, 200, 300, which gets assigned to x and y. It uses that to create this, to define the size of a graphics window, and also to define the center point of a circle. So there's a graphics window that gets created and a circle that gets created and drawn, and then the make function returns those two values as a tuple once again. So where do these two values go? When the make function returns them, they get assigned through this syntax, they get assigned to these two variables in main. This is something you did for programming exercise 2-3 and earlier programming exercises in labs, and absolutely this is something that you need to do for lab 2-3 and milestone 2. We're going to be having functions that return more than one value or that get passed more than one argument. Those are tuples as well. So all of these examples utilize a tuple in some way to manipulate, pass, or refer to multiple variables at once, all at once. All right, that is our discussion on tuples. And we will move on, take the quiz on this one, and move on and watch the other video.